Hello again and welcome back to our course on Excel 2013 Advanced. In the previous section I left you with a little exercise to do. I'm going to take a very quick look at that now, and then we're going to look at some of the more advanced financial functions, some that's maybe of more interest, say, to somebody who is involved in financial services professionally. But let's start with that example. Now, the reason that I want to briefly look at this example here is to just emphasize a point that I've made a couple of times already, and that is that in this particular case I've worked in years. So I've got an annual interest rate there in C2, and the answer in C6 is the number of years, 10.34 years. That's not a particularly convenient way of expressing a number of years, but it is the correct number of years. If you worked in months, then your formula, including the P duration function, which is in cell C6 and currently displayed in the entry bar, would have the annual interest rate, which in my case is C2, divided by 12, and then what would be expressed here in C6 would be the number of months. So if I'd say had, let me just type in there now, divided by 12, and click on the entry, and I'd find that it is 121.84 months, 122 months, which is about 10 1/3 years, which is the same figure obviously, but expressed in months. So if when you were working on this example you worked in months, then your formula would be something like this. Now, of course, you may have chosen different present values and future values to mine. You may have put in a different interest rate, but your formula, if you were working in months, would look like that. And the function, the P duration function's arguments, will be used in a similar way to that. So now let's take an example of a more complex kind of analysis of payments on a loan. I'm again assuming that this is a loan to buy a house. I've set up the sort of argument values that we've seen already. So I've got an annual interest rate of 4%. The number of periods is 180 months, so that's 15 years. The amount of money borrowed, $150,000, and FV0, and the type is 0 as well. And I've entered in cell C8 the monthly payment that's calculated by the PMT function. And you'll see there with the PMT function that the arguments are C2 divided by 12, C3, C4, C5, C6. Now, when you take out a loan of this sort and you start making regular payments on the loan, of course each payment will generally comprise both a repayment of the principal and a payment of interest. And in a payment like the one we have here, which is $1,109.53 per month, part of that is principal and part of it is interest. And the interesting question is, in the first month, how much of it is principal and how much of it is interest? So what I'm going to do now is to put in a month heading, and let's start with month 1, and I'm going to calculate for the month 1 payment how much of that payment is principal and how much of it is interest. Now, the function that tells me the part of the payment which is principal is the PPMT function. So I'm going to type in equals PPMT, there it is, and let's look at the arguments. The function arguments we need are the rate, which is that one, of course, divided by 12 because we're talking about monthly payments. PER is the period, and so it will be in the range 1 to n per, the number of periods. So it'll be a month number in the range 1 to 180. Now at the moment that is E2 because we're looking at month 1. Now the number of periods is C3. PV, that's the loan amount, that's in C4. And FV there. Now in this function it does not distinguish based on type, so I'm not going to put in a type value. Now, having done that, I click on OK, and what I discover is that on that first month the amount of principal is $609.53. Now, from that I'm pretty sure you can work out what the interest is going to be. But there is, of course, an interest function, and we'll look at the interest function next. So the interest function is IPMT, there it is, and it requires pretty much the same arguments as the PPMT function. So again, I can say it's the rate there divided by 12. The period number is month 1. Total number of periods there. PV there. FV there. Click on OK, and you won't be surprised to learn that the interest on that first payment is $500. So obviously it can be really useful to know what that split of principal and interest payments is. And what's going to happen, generally speaking, with any loan is that as you pay off the loan, each month or each other period, depending on how you're paying it off, the interest will diminish because you'll be paying off some of the principal. So each month there's a little bit less principal left and therefore a little bit less interest to pay. So you pay a bit less interest and a bit more principal each month in this case. If we wanted to see the split over time and how it changes over the duration of this particular loan, we can actually now extend this from month 1 to month 180. So let's start by getting the month numbers from 1 to 180 in column E. Now, of course, I'm assuming you're familiar with these kinds of techniques, but quickly covering this, we're going to use a series fill here. So in the editing group on the home tab, we go to series. It's a series in columns. It's a linear series. The step value is 1. The stop value will be 180. Click on OK, and of course we fill down to 180. Now what I'm going to do next is obviously going to be a mistake, and what I'm going to do now is to just say try doing a fill down of those principal and interest values. So what I'm going to do is select those two cells, the cells below, and just do a regular fill down. Now, of course, the answer is obviously wrong, and hopefully you know why the answer is obviously wrong, and that is that if I look at cell F3 and the PPMT formula in it, look at what it says. It doesn't say, for instance, C2 divided by 12. It says C3 divided by 12. And the important thing there is that we haven't used absolute cell references where we needed to use them. And of course the key point there is that you still have to use absolute cell references in the appropriate places. So let me just undo that again, and let's look again at the way we've set up the arguments in the PPMT function. What I'm going to do there is to click on functions to bring the function arguments dialog back up, and let's look again at each of those arguments. So let's look at how we defined this in the cell F2. So this is the principal payment PPMT for month 1. Now the rate we put in as C2 divided by 12. Now whichever period we're dealing with, the rate is always going to be in C2. So the correct argument here would be $C, $2. The period, E2, that is going to vary because as we work down the 180 months, then that will vary. You could, in fact, use $E to say it's always column E, and then it's only the row number that varies. But in fact, in this case, E2 would be fine because we're never going to put a month number somewhere else, having set up this series from 1 to 180. Total number of periods, N per, C3, that's always going to be C3, so we ought to have there $C, $3. And then similarly for PV and FV, they also ought to be absolute references. So what I'm going to do now is to correct those other couple of entries there, and then I'm going to do the same for the interest payment definition, the IPMT function use in the formula in G2, and then we'll see if our fill down gives us a better result this time. I'll join you again in just a moment. So let's try a fill down now. Let me choose, say, the first 3 or 4 months. Fill down I can do from the ribbon, or I can use the keyboard shortcut Control D. So let's do a Control D. And let's see, now that looks a lot more like it. We have interest payments going down, $500 month 1, $497.97 month 2, and so on. And if you look at the IPMT function arguments, as I click on these different cells, you can see that the only thing that changes is the row number there on the second argument, which is the month number. And similarly, as the interest payments go down, the principal payments go up. So let's select right down to the end. Let's do a fill down to the very end, and just need to make that column a little bit wider, and you can see that just about month 180 the interest payment in the final month is only $3.69. And of course, if I just wanted to check that the total principal paid looked right, if I select the cell below the last entry in column F, the principal column, and do an auto sum, what do you think it'll say? It says $150,000, which is exactly right. So, having built up a more advanced model of the use of financial functions, in the next section we're going to look at a different aspect of the use of financial functions, and we're going to look at the approaches we can use to depreciation. That's in the next section. Please join me for that.